Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at compiling your applications on the command line, auto-building for continuous integration. In the last video, we covered the topic of continuous integration, whereby all the applications you have created can be built in one system. This system will build each of your applications one by one and report whether the build has been successful or a failure. We achieved this in the last video by creating a simple build batch file. This build batch file would create two virtual folders on the hard disk of your computer. It would then compile each of your applications on the command line with the appropriate PowerBasic compiler. What we're going to do today is we're going to create an application to perform this compilation for you. So let's have a look at the code. Now we have the standard basic template here, pulling in some libraries we've created before. The file handling routines to allow us to create and add to log files, the shell library to allow us to shell out to the command line, and also the command line library. For today's application, I'm going to add another library. I'm going to add the date functions library. I'll cover that when we come to it. Now, we're going to need a couple of globals here. We're going to need a global for our log file. The log file is going to contain a list of everything we're doing. And I want at the end of the application to produce an HTML version of this log file, so we can display to the user in a nice web page the list of all the things we've compiled and whether they've been successful or not. In the batch file, we started off by creating a couple of virtual folders. One for the location of our code and one for the location of the compiler's API. Now today we're going to be compiling both console and Windows applications. So we're going to create not only an X and a Y virtual folder, we're going to create a Z one as well. We're going to create an X drive mapping for the PowerBasic console compiler's Windows API folder. I'm going to create a Y drive, which is going to be where all our code is going to be sitting. I'm going to be creating a Z drive for the Windows API folder of the Windows compiler. And we're going to create a couple of constants, one for the console compiler and one for the Windows compiler. Now, having done that prep work, we move into the PB main function. Now, though this application is intended to run in the background with not anybody watching it, we may want to put something on screen just to help us during the development of this application. So what we're going to use is we're going to use a graphics window. Now we're going to create a local variable, which will be the handle to the graphics window. We're going to title our graphics window Auto Builder. We're going to put it onto the screen 530 wide and 270 tall. We can then attach the graphics window to our handle. We're setting this one to redraw, which means nothing will be displayed until we use the redraw command. We're going to put a box on screen, which is going to be basically a progress bar. And we're going to set the font for our graphics window to Courier New, 18 point. Right, this will give us a nice little auto builder window on the screen. Now it hasn't displayed anything in the graphics yet because we haven't issued the redraw command, but that's what should come up. Now we'll also want to create a few more local variables. One which is going to be an array, and this is going to contain the list of files we're going to be compiling. The str build file is going to be the individual file we're actually going to be compiling, and we want to keep a track of the number of failures and the number of successes. Now what I'd like to do is, rather than having a batch file with everything written down, we're going to be using a flat text file which is going to contain the list of all the files which we're going to compile. So this is our build list, and this is a list of applications we're going to attempt to build. Now I've set 4 columns up in this little file: a folder name, a type, a file name, and what it delivers. The folder name is the folder inside which the source code actually sits. The type is the type of compiler we're going to have to use to compile this application. So there are 4 console compile applications and one Windows application. The file name is the name of the file we're going to compile, and in the delivers column is what we're going to get out of it. Now, because of the way we're setting this one up, it won't really matter because the file name will define that it's going to be an exe, or whether it's going to be a DLL, or whether it's going to be a statically linked library. But knowing that this is going to be the name of the file we're going to be producing, we can actually test for that at the end of the code. Now, while this is a flat text file, this could of course quite happily come from a database. Normally when you're doing a continuous integration, you would expect to get all the source code from a version management system. Now today we have all our files quite happily sitting in a source folder. So we're going to assume that you've already extracted from your version management system, whatever that is, all the source code. And in each of these folders is just the source code. We have no exe, we have no log files. So our first task in here, having set the graphics window up, will be to define our log file. This is the flat text file, which will contain details of what the program's actually doing, which you can always look at after the program's finished, just in case there's been a problem. So the global variable we'd set up, the str log file, is going to be created in the execution path, and it's going to be called logofbuilds.log. Now the one thing you'll want to do before each run of this application is to make sure that this log is actually purged, and the easiest way to do that is just use a kill command to kill it off. But we can wrap this up in a try catch to ensure that this will not generate an error at runtime just in case the file is not there. And having purged the log file, we'll also want to create an HTML file. So we'll do exactly the same for the HTML file. We'll create it in the root of the executable, and we will attempt to wipe that file at the beginning of the program to make sure that no files are lying around from a previous build. So having got our log file sorted out, the next thing to do is to load our build list file, which we looked at a moment ago, into the program. So we're going to load this entire file straight into our application. We're going to use one of the functions we've used in a previous video, the fun read the file into an array, which takes a flat text file and reads it straight into an array. Then we're going to step round each element in that array and process. Now if that array cannot be populated for any reason, we will push a message out to our log to say that we can't read it. On the assumption that we can read the file, we will initialize our two variables we set up for the successes and failures to make them 0, and we'll want to run our build. So let's create a function to build the code. Now if the build code is a success, we can put out to our log it's completed, and if the build code returns a failure, we'll churn out a message to our log to say that it has in fact failed. And at the end of this function, we can effectively close off the font we created. So all we have to do now is to create the build code. Now we'll want to pass some parameters into this one, so we can get back the number of failures and the number of successes. And we'll also want to pass in the array that holds all the things we're going to build. So 3 simple parameters to pass to this function. So next thing to do is to create our function. Now this is going to return a true or false to say whether it worked or not. Now we're passing the array by reference, and these are going to be longs. So build code is going to actually look through our array and build our projects. Now what we haven't done yet is we haven't assigned our virtual drives. So one of the first tasks that our build code is going to do is to create these virtual drives. Now, as you may run this application on a machine almost continually, perhaps periodically every hour, twice a day, the machine, once it's created these virtual drives, will maintain them until you reboot the machine. So as well as creating these virtual folders, we'll have to make sure every time we attempt to create the virtual folders that they do not already exist. So we'll need a function basically to check the virtual drives are set up and continue quite happily if they have already been done so. So we're going to create a little function to do that, and we'll build that in here. We'll call this check virtual drives. Now we'll create that one first, and we're going to be calling on the command line for these. So we're going to populate this variable str command with the command we want to launch, which is basically what we had in the batch file. So what I'm going to do here is I'm going to do a test. We're going to use the isFolder function, which is inbuilt to PowerBasic, to check to see whether our Y source has already been created. Now if that's false, it means we have not yet created our virtual drive. Therefore we can use the substitute Y command using the constant for AutoBuilder, and we're going to run one of the inbuilt functions to our library, our shell library, to launch that command on the command line. And then having launched that, we will then test to see whether the folder actually exists, which it should do at this point, so this should return true. If it returns false, then we're going to exit the function. And we're going to do the same for the X drive. We're going to test if the Win32 API include file exists in that folder. If it doesn't, then probably the virtual drive hasn't been set up, so we'll then attempt to set it up, and then we'll test to see whether the file now exists, which it should do. So that's our Y and our X, and the last one to do is the Z drive. So same approach with that one, we'll test for the Windows 32 API include file in the Z drive. Now if we get right to the end of this function, then everything should have been set up or will have already been set up. Therefore we can return true to the function. So if the drives have not been set up, this routine will set them up. If they have already been set up, this routine will return true, basically to say they have been set up. So having done that, the other thing we haven't done yet is we haven't created our log function. So let's just put the log function in here. This is the one that will append to our strlog file. For example, if we are unable to set up the virtual drives, we'll call funlog with the string and it will append that data that we're giving it with the date and time to the funlog. Every time we call the funlog function, it will take one parameter, which is the string you wish to put into the log. It will put that string into the log as a new line at the end, prefixed with the date and time. So in our build code, we've successfully set up our virtual drives. Now we're going to need some local variables to keep track of things. So we'll just create them up at the top. So these are basically for the information we're pulling out of our text file. We'll need the project we're going to be building, basically the folder name, we'll need the type, we'll need the file name, and we'll need what it actually delivers. So we're going to put all of that into these individual variables. So after we've created our virtual drives, we're going to do a for next loop. Since we're taking in the parameters, the name of the array, it's this array we're actually stepping through, and this will be each of the applications that we wish to compile. And long max is going to contain the maximum number of things we're actually going to build. So we're going to populate into the strdata variable the entire line of text that sits in this array, which will be one line. For example, this line. We're going to ignore all the lines that begin with the single quote as their comment lines. So the first thing to do is to test if it is a comment line we have actually got. And if that's the case, we can then use the iterate command to go to the next value of long R. We now want to pick up the 4 values that are in that file: the project, the type, the file name, and delivers. We're using the parse command on strdata since everything is pipe delimited. We're taking the string here and we're trimming it to remove the spaces off the end. And for the type, we're forcing it to uppercase, just in case whoever's made this file in hasn't pushed these to uppercase. It says in the testing later on. Now, having done that, we're ready to start the compilation of our first one. Now, we've created a graphic screen at the beginning of the program. We now want to actually advance the progress bar on that. So we'll need a function to basically advance our progress bar and then redraw the graphic screen so if anybody's watching it, they can actually see what's happening. So we'll create a function called setProgressBar based on long R and long max. This tells us what number of project we're actually working on, i.e. the first or the second, etc. And long max is the total number we're doing, so that way we can have a percentage display. And strProject is something we can display on screen just for the user watching it. So let's create the progress bar function. Now it's taking in 3 parameters, so we'll have them at the beginning: long R, long max, and strProject. And in here we will set the progress. Now most of this is working out where we have to appear on screen, what size we can have to go up to, and to make sure we don't go greater than 100%. So just in the off chance that long R gets called, we're making sure it doesn't get any bigger than the maximum number it can be. And then we're quite simply working out the percentage value. So how close to the 100% are we actually getting? And then we want to draw a graphics box on the screen from our start position to our percentage. And it's going to have a black border and a red fill. We'll then set the position on screen to allow us to put the text onto the screen to tell the user what it is we're actually doing. So we're going to be telling the user that we're actually going to be building, and we're going to give it the project name, and we're going to pad that out with spaces because each time we're going to overwrite this area of the screen. So if we have something that has a long name, if we didn't trim this down, then the remaining characters would still show on the screen. So this should quite happily display our information. So that compiles quite happily. Okay, we've drawn the progress bar, so we're ready to actually do the compilation of our first application. What I'm going to do is create another function to actually build the individual project. So this will take 4 parameters: the project name, the type of project we're building, i.e. console compiler or Windows compiler, the file name to be compiled, and what it delivers. If that returns a true, then there has been a successful build and we can increment the counter for build successes. If it returns a false, then we will increment the build failures. And if we get to the end, we can return a true, because it has reached the end of the compilations. So all we have to do now is to create the routine that actually does the building. So we have 4 parameters: the project, which is a string, the type, also a string, the file name, again a string, and what it delivers, again a string. So we're going to build the individual project within this function. So we'll set up our local variables. str command to contain the string we're going to pass to the command line. We have our build log file, we have our build details, we have a log, and we have a build state. So the log file is the log which is going to contain the output of the compilation. So we're specifying the log file first, which is basically we're taking the 4 characters off the end of the file name. So if our file name is commandline.bas, we're just populating in the log file command line. And we're going to populate a batch file. And it's the batch file we're going to be calling that's going to individually build this particular project. So the first thing to do is to kill off any script file that's lying around. So we use a try catch on that one. Now, since you may be doing continuous building here, there may be an executable or even a log file lying around from the last compilation. So the first thing to do would be to remove any previous builds and log files. So since we're passing in what it delivers to know whether it's an exe or whatever, then we are using the try catch again with a kill to go into our source mapped folder for the project and remove what it's delivering completely. So that will kill off any exe, any DLL, or any static linked library. The next thing in our tidy up is to remove any log file by the same process. So we're taking our project and we're removing the project with the log attached. So the next thing to do is to create our script.bat file. Now, as we saw in the original batch file, the first thing we wanted to do is to change the directory to where we're actually going to be doing the compilation, to where the source file is. So what I'm going to do is I'm going to use a function from our files library to append to the script.bat file. Now we've already erased the script.bat file, so since this file doesn't exist, it will create it, and it will do a switch to the Y drive, and then it will change directory to where our source code actually sits. And we're using the $dq to add a double quote so that these, should they contain spaces, will still be handled quite happily. Now we're going to be compiling either a console app or a Windows app. So since they're using slightly different applications, we'll need a select case statement in here to decide which one we're doing. And again, we're going to be adding to the script.bat file we have already created. So first thing to do is to append to the file, and then we're going to be telling it the path to the console compiler. So we created a constant for this one earlier, as you remember, at the beginning of the program. And the next thing is the definition of the log. And since no one's going to be watching the build, we want to run it in quiet mode. Therefore, there'll be no pop-ups. And finally, what we need to do is to tell it what it is we're actually going to be compiling. So we're going to give it its libraries, the X drive for this case, which contains the Windows API, and the Y drive, which is going to be our project and our file name. Again, everything wrapped in double quotes. Now that will populate our script.bat file for the console compiler, and we'll take exactly the same approach for the Windows compiler. The only difference being we're using the pbwin constant and the Z drive. Now, since our batch file is now fully prepared, we're going to be calling the command line. So the first thing I'm going to do is use the clear command to ensure there's no error lying around. And then we're going to use the command line function to execute our script.bat file. Now our program will wait until that is actually completed, and at that point we want to test to see whether it has actually worked or not. So we can test the value of the error variable. If it's not 0, then it failed. Otherwise, it worked. Or at least it generated no errors. So we'll need to check to see whether this has been a successful build or not by having a look at the log. We know where the log file is. It's in the Y drive, in our source folder, inside the project, and it's called what will be called the log plus .log on the end. Now we're going to use another one of our file functions in the library to pull that entire file into a string. Now, if for any reason that string returns an empty len string, then obviously the file does not exist or is completely empty, in which case we failed miserably to build. Otherwise, we do have something in the log, so we need to look to see, is what's in the log actually okay? Now, if you look at these logs, you'll find that if you do actually manage to successfully build something, then there will be a file, a disk image sitting there. So we can test that by looking inside our variable, using the instring command to see, does it contain the words disk image and a colon? If it contains that, then it has actually compiled and created an output. And that is enough to know whether it is actually compiled or not. So if that's the case, we can then say, well, that's a success. If it didn't do that, then it's a failure. There's been some kind of error which we can report to say it's failed. Now at the moment we don't know what error it is, just the fact it's actually failed. So there we have our build routine. So we're calling on the command line to run this batch file. If it returns an entry inside the log file with the word disk image and a colon, then we're assuming that the execution has been a success. So we'll see in our source code folder we have 5 folders, one for each of the applications which we're going to be compiling. So if we go back to our code folder and attempt to run our auto build, we'll see that the graphics window quite happily steps through the 5 applications to build quite quickly and will produce a log of builds.log. Now this tells us that there have been 3 build successes and 2 build failures. So this is fine for how far it goes, but it's not telling us any detail, it's just giving us a number of failures. What we want to do is produce something that the user can actually use to see what's failed. So we're going to enhance this slightly before we investigate what these failures actually are. So what we want to do is we want to actually populate a HTML file. So this is going to be a fairly simple HTML log file. It will contain the HTML tags to create the HTML file and the body of the HTML file with a title of auto build log, and it's going to create a table with a number of columns: project, type, build state, and we're going to have in the final column, which is going to be a link to where the log file actually sits. Now we'll use our routine to append to a file, which will push this piece of HTML out to our HTML log file. And when we get to the end of all the builds, we'll want to close off that HTML file with the end tags to end the table, to end the body of the text, and to end the HTML file itself. And then save that string into the end of our HTML log file. So that'll create the header and the footer of the HTML file. What we need to do now is to put the content in. So if we go back to our build project, where we're building the individual project itself, we're going to build up a line of HTML to put into our log file. Now this is going to be a new row in our table, and then 2 new elements, one saying the project and one saying the type of the project. And then should the function return false, we'll want to say that it has actually failed. So we'll put a bit of HTML in there, and we will add that to the existing build state. So build state is going to be what build state was, plus it's going to have a new column which is going to be in red background with the word failed. So we'll do exactly the same for each condition where it fails, and for where it's been a success we will put in a different background colour and the word success. And at the very end we want to put a link into the log file, and we will fire that out to our HTML log file. So this hopefully should create a link at the end to our log file. Right, that compiles fine. If we try running that now, it will run through as before, and we can have a look at our file. We now have a log of builds HTML file. So if we have a look at that, it creates something that's a little more useful. It tells us which applications have successfully built and which applications have not. And it also gives us a link to the log file to tell us what the problem is. Now in this one, in line 5, it's discovered a piece of text which it cannot compile, which is expected. And in the screen metrics one, it has complaining the fact it can't find a library file. So this makes it much easier to actually see when you have maybe 50 or 100 applications to compile, which ones have worked and which ones have not. And of course, having done that, you can see what the error is, and you can go in and correct the error and then recompile again. Especially useful where you've changed something in a common library and many of your applications may depend on that common library. And knowing quickly when you've actually broken a common library and a number of applications is very useful indeed. However, that's it for today. Thank you for watching.